When you solve an absolute value equation, what do you have to do?
Get the absolute value right.
Yes. First step, isolate that absolute value. So I would have to add over my 3. Now I have an absolute value equals a number. So what do we do from that point? We set up how many different equations? 2. We drop the absolute value, so one of them, we just say equals 12. 1 equals negative 12. Okay, add our 4, divide by 3. So over here, add our 4, divide by 3. How do you check your answers on these?
Not yelling, talk loud so everybody can hear.
How do we check answers?
Well, you try.
Plug them back into the original. And you could easily do that if we put in 16/3. The absolute value of 16 minus 4 is 12, minus 3 is 9. Put in negative 8/3, the absolute value of negative 12 is 12, minus 3 is 9. So they both work. All right, then we did our inequalities. First step is the same. The absolute value has to be by itself. Then we had to remember if it's greater than, that's an or. So we should get 2 different pieces at the end. Less than is an and so we would get 1 piece at the end. But what's special about B when I look at it?
5 is not going to be negative.
It's a negative. So an absolute value is what kind of number? Positive. If you have an absolute value by itself and a negative on the other, you don't really have to work it out. You can just think about it. How often is a positive number bigger than a negative number? Always. So my answer on this one is negative infinity positive. What if it had been a less than? When is an absolute value less than a negative? Never. So it would have been no solution. All right, C. What do I have to do first here? Get that absolute value by itself, so subtract our 4. Okay, is this an and or an or? And. So there's 2 options. I like to set it up between the negative and positive and solve one big inequality. You do that, you add your 3 to both sides. And we get here. Some of you are doing it the way Mrs. Keller did last year, which is fine. So you have the first one and the second one. You flip the sign and make it a negative. Okay, when we did the ors, we always did this. We wrote 2 separate ones. So if you solve this, you get x is less than 6. X is greater than 0. If you do the 2 separate ones, you do have to kind of think about the graph at the end. Less than 6 would look like that. Greater than 0 would look like this. If it's an and, you are taking the overlap. What got shaded by both of them? Everything from 0 to 6, which if you've done it this way, you see as well. X is just between 0 and 6. How do you know if you need parentheses or brackets?
If it's or equal to.
Right. If it has an equal to, that's a bracket. Otherwise, it's parentheses. Okay, so that was the first piece. Absolute value equations and inequalities. Questions about any of those? The next thing we went into were piecewise functions. So for instance, if I said you have a function when I had you graph piecewise functions, what did we have to do? T-chart. And we did a separate T-chart for each piece. right? So if I'm looking at the first piece, I said x is less than 4. So we still have to plug in the 4, but what kind of circle would that be? Open, because it didn't have an equal to. Now, if I gave you other requirements, sometimes I would tell you x is between 0 and 4. In that case, you have to put in both the 0 and the 4, and then something in between. Here I just said x is less than, so we start with the 4, and then we do anything smaller than that. So maybe a 3 and a 2. Okay, so 4 plus 3 is 7. 3 plus 3 is 6. 2 plus 3 is 5. We graph that. So 4, 7 is open. 3, 6. 2, 5. And it continued for less than. If you had 2 endpoints, it was just a segment. It didn't go on forever in either direction. Next one. 5 if x equals 4. So the only x I can plug in is 4, and we get out 5. How do I graph that? What is that? Well, this, since it's just 1, it's even just a point. 4, 5 is just a dot. Closed circle. Okay, the last one. X minus 5 if x is greater than 4. So we still have to plug in the 4, but then we do things larger. The 4 didn't have an equal to, so that's open. So 4 minus 5 is negative 1, 5 minus 5 is 0, 6 minus 5 is 1. So 4, negative 1 is open. 5, 0, 6, 1. And I told you at the end, double check that it passes the vertical line test. This is a function, so it should. If it doesn't, that means that somewhere you plugged in the wrong numbers or plotted them in the wrong spot. Questions on that one? The last thing we did on Thursday was something that was totally new. It was the greatest integer function. I have told you there's not going to be a huge emphasis on this, but it does come up, so I'm not just going to skip it. So that was our greatest integer. So let's graph one of those. If I said greatest integer of x minus 3. We did the t-chart, but I told you you cannot just plug in integers. So we usually started at 0, did like 0.5, 0.9, and maybe 1. And then saw if we needed more points from there. If I put in 0, 0 minus 3 is negative 3. What is the greatest integer of negative 3? Well, negative 3 is an integer, isn't it? So if it is an integer, we just get that number out. So 0, negative 3, we got that number out. So it is a closed circle. It is an actual point on my graph. If I put in 0.5, 0.5 minus 3 is negative 2.5. What is the greatest integer of negative 2.5? Negative 3. So when I put in 0.5, I'm still getting out negative 3. If I put in 0.9, 0.9 minus 3 is negative 2.1. What's the greatest integer of negative 2.1? Negative 3. So I'm still getting out negative 3. But when I put in 1, 1 minus 3 is negative 2. Negative 2 is an integer, so that's the number we get out. So at 1, it's negative 2. Has to be a function, so underneath that we put an open circle because we are getting out the -3 up until that point, and then I get out the -2. So once you have one step, you kind of know what your graph looks like because it'll follow the same pattern. I have a closed circle on the left, open on the right, it's 1 unit long, and then I would jump up one. Closed on the left, open on the right, 1 unit long. How many steps did I tell you had to graph? 3. You can do more, but a minimum of 3, and then I ask that you put the ... to show that this does continue. It's just these stair steps forever. Questions there? Okay. So what we are going to do now, I have a review handout for you. The front is all the absolute value steps, so equations for the first 4, inequalities for the next few. The back is the graphic. Make sure you read your directions. It does ask you to do a couple things on those, so follow those directions. So today is just time to work and ask questions. I do not mind if you help one another. Also ask me questions. We will stop with probably 10 minutes left at the end of class and grade those 2 handouts from